one here, and it says, it was question 15 in one of the papers, past papers. It says the work function of three metals. So they are giving you work functions, okay? The work function of three metals is shown in the table below. So you've got zinc, you've got aluminium, you've got silver, and then these are their work functions, okay? You need that amount of energy to get electrons ejected in a surface of these metals. Now let's look at the first question. The first question says, give a reason why, okay? Now this is important. You're giving a reason why different metals have different work functions. Now why is it like that? Now you know that when we talk about metals, they've got what we call ionization energy. Now different metals will have different ionization energies. So we'll say that different metals have different ionization energies, okay? Ionization energies. And for this reason, they will have different work functions. Now, somebody might ask, what is this ionization energy? Now, this is an energy needed to remove an electron from a metal, from an element. So if it's a metal, it will be an energy needed to remove an electron from that metal. So because these energies are not the same for different metals, for zinc, for aluminium, for silver, we will have different work functions. So that is the reason why. So for that, you were just waiting for 1 mark. So you would see that it's not much of a problem. You just have to understand what's happening here. But here, the next question, 15.2, look at what you're waiting for. You're waiting for 6 marks. Really, you have to apply yourself here. Now, let's look at the question. Light of wavelength. Now, this is important. You must be, when you read a question, make sure that you take out the important parts of that question, what you need to work out your solution. And I think this is what Peter always says. You read a question, be careful, take out all the details that is important for you to answer that question. One of the details important for you here, part of it is the fact that they're giving you the wavelength. And it's 2.3 by 10 to the power minus 7. And they are telling you that this light is shown on a metal that we don't know, so we call it X. The average speed emitted, the average speed of the emitted electron is 4.78 by 10 to the power 5 meters per second. Now, this is another important piece of information. You have got the velocity there. Identify the metal X by performing a relevant calculation. Now, let's look at it carefully. Right? We've got here, we've got the wavelength, lambda. It's 2.3 by 10 to the power minus 7 meters. We are also given the velocity. We are told is 4.78 by 10 to the power 5 meters per second. This is the velocity of the electron. Now, you would see that we're talking of an electron. So we're not given the mass of the electron as such in the question. But the question requires us to use this mass. So we need to know what it is. You must know that the mass of an electron is 9.11 by 10 to the power minus 31 kilograms. Now, you don't have to cram that number. It is given to you in the information section of that paper. You just go the page through, look for the mass of an electron, and you get it. Now, the question says we need to perform a particular calculation to determine this metal X. So we need to know what metal X is. So we go to the equation, we go to our formula, okay? Go to our formula. We know that the energy of a photon, HF, is given by work function plus EK, okay? Now, we know H, all right? H is Planck's constant. It's 6.63 by 10 to the power minus 34 times the frequency. We don't know the frequency, is not given to us, but indirectly it's given to us when we have the wavelength here, because we're given the wavelength. So how do we get frequency from that? Frequency, F, is equal to C over lambda. Okay, so we're going to substitute that into the main equation. So here we'll say that will be equal to, what is C? C is a constant as well, 3 by 10 to the power 8 divided by, what is lambda? It's given to us, 2.3 by 10 to the power minus 7. That should be equal to work function, what we're looking for, plus a half, what is m? Half mv squared. Remember, EK is half mv squared. What is m? Now, remember in the exam, you need to really put that in so that when you substitute into it, you get marks for that. Okay, don't forget that. So here, I may not have all the time to do that. So just know that you have to do that. So this will be half times, what is the m? Mass of an electron, 9.11 by 10 to the power minus 31. Okay? Then what is V? V is given to us there. What is V? The value of V is 4.78 by 10 to the power 5. But remember, this is V squared, so you need to square that. Now you work this out, it will come to your work function being 7.61 by 10 to the power minus 19 joules. Now, the question was, we need to find out what this metal is. It means that this work function is actually associated with some metal there. We go back to the information given to us here. We see which one has a work function of 7.61. Definitely it's this one, although we're not getting it as exact, but they won't penalize you for that in the exam. They know such fluctuations may happen, and so that is what you have. It would mean that the metal X, right? So metal X is silver. Okay, it's silver.
All right, Mr. Khosa,
Right.
We've got a caller. We've got Tulu Fellow, right, from Hammanskraal. Hello, Tulu.
Hi.
Hey, throw us a question right there.
The statement goes like this. When the radiation of wavelength 5 nanometer is incident on the metal plate, electrons are released.
5 nanometers, just a bit slowly, Tulufelo.
Is incident on the metal plate, electrons are released with zero kinetic energy.
Can you say that again? 5.
When the radiation of
Yeah.
wavelength 5 nanometer
Yeah.
is incident on the metal plate,
Yes.
electrons are released with zero kinetic energy.
With zero kinetic energy, okay.
Yes.
E with 0 EK, yeah?
The question goes like this. Calculate the work function of this metal.
Calculate the work function of this metal. Okay? Now, if you are told that these electrons are ejected with zero kinetic energy, it tells you that the energy that comes in through that photon is exactly equal to the work function of that metal, and therefore this will be HF naught. Now, what is F naught, Tulufelo? F naught is what we call threshold frequency. Do you know what that is? That is the minimum frequency needed to remove an electron from a metal surface. Are you okay with that?
Yes.
Okay, good. Now, what it means here is that you have the Planck's constant, 6.63 by 10 to the power minus 34. Are you okay with that?
Yes.
Times the frequency. You see that you are not given the frequency, but you are given, what is that? That is lambda. So you would say that to get lambda, I need C, to get frequency, I need C divided by lambda. Are you okay with that one?
Yes.
Okay, good. So this would mean you've got 6.63 by 10 to minus 34 times C is 3 by 10 to the 8 divided by, what is lambda? 55 nanometers. Tulufelo, what will this be in meters? What is 55 nanometers in meters?
5 times 10 to the power minus 9.
Very good. 5 times 10 to the power minus 9. Then we work that out. Let's just work it out quickly. Let me take out my calculator. We've got, therefore, here we've got we have 6.63 by 10 to minus 34. So minus 34 times 3 by 10 to, by 10 to 8 and divided by 55 by 10 to the power minus 9. Okay, minus 9. So what is the answer there? We get the answer there to be 3.62 by 10 to the power minus 8 joules of energy. Okay, now this was minus 34. I left out the 4 there. Are you okay with that answer, Tulufelo?
Yes.
Okay, good. Any other? You're fine, thank you.
Okay, Tulufelo, I hope that that's what